Hi, my name is Menelaos and I'm a mechanical engineering student at the University of Leeds. As part of my placement at National Instruments, I worked on a week-long individual project using the myRoboLab embedded controller. As a robot enthusiast, I had an ambitious plan. Without any prior knowledge or experience, I wanted to design and program a robot completely from scratch. My learning curve was accelerated as I chose LabVIEW to program and control the robotic arm. As LabVIEW is an intuitive graphical programming language, this allowed me to spend most of my time working on my application rather than learning how to use the software. Let's begin by having a look at the project in more detail. Using computer-aided design software, I designed the robotic arm from scratch in such a way that each individual part could be laser cut out of acrylic or 3D printed. Once the project starts, the user can calibrate the motors to the configuration specified. Let's take a look over the modes of operation. The first mode of operation is forward kinematics. Forward kinematics refers to the use of the kinematic equations of a robot to compute the position of the end effector from specified values of the joint parameters, in this case being the position of the servo motors. In simpler words, by changing any angle, you change the current configuration of the robot and thus changing the position of the clamp. Here you can see that as we change an angle, the robot moves to the specified configuration in a smooth manner, and at the same time the simulation running on the computer moves in synchronization. The second mode of operation is inverse kinematics. Inverse kinematics refers to the use of the kinematic equations of a robot to determine the joint parameters that provide the desired position of the end effector. This means that by setting a desired position of the clamp, let's say x16, y4, and z0, it is able to calculate the position each motor needs to be in order to reach the desired position. The final mode of operation is trajectory planning. Trajectory planning refers to moving the manipulator arm from an initial position to a desired position through an intermediate point, usually for obstacle avoidance. For the purpose of this demo though, I have set the robot to close the clamp at the intermediate point in order to grab and move the object to the final position. Choosing an appropriate architecture for the code is crucial since the project was just a week long and I was looking to add all three modes of operation. Since we are looking at different functionality depending on the button pressed on the front panel, using a queued message handler architecture is ideal. In all three modes, the desired angles are identified in the host computer, which are then sent to the program running on the real-time target of the myRoboLab. The real-time target is responsible for incrementing the current angle to the desired one in order to provide a smoother motion of the robot, and converts that angle to duty cycle. The current duty cycle is continuously sent to the FPGA target in order to move the servo motors by converting the digital channels to PWM. At the same time, the real-time target sends the current angle of each motor to the host computer in order to move the simulation in synchronization with the actual robot. As I was able to complete this project without any prior robotic knowledge, then anyone can do it. Please visit the community page for more information about this project and get access to the code and CAD files.